Hello, welcome to NEF Center. Today, we will talk about vectors. Everything that moves in physics, including a car, a football, an airplane, or even the Earth, is described using vectors. A vector tells us two things: its magnitude and its direction. Imagine someone tells you, walk 5 meters. This instruction is incomplete because you do not know where to go. Now imagine someone says, walk 5 meters toward the north. Now you know both the distance and the direction. That is a vector. The red arrow represents a vector beginning at the origin. The coordinate axes, x, y, and z, allow us to describe motion in three-dimensional space. Mechanics is the science of motion, and vectors are the language used to describe motion. Scalars and vectors. Physics uses two kinds of quantities, scalars and vectors. A scalar has only magnitude. Examples include a mass of 5 kilograms, a time of 10 seconds, a temperature of 25 degrees Celsius, and an energy of 100 joules. None of these quantities require a direction. A vector has both magnitude and direction. Examples include a force of 20 newtons toward the east, a velocity of 60 kilometers per hour toward the north, an acceleration of 9.8 meters per second squared downward, and a displacement of 5 meters toward the west. Without direction, these quantities are incomplete. Suppose two people push a box. One pushes with 50 newtons toward the east, and the other pushes with 50 newtons toward the west. The forces have the same magnitude, but opposite directions. As a result, the total force becomes zero. Direction completely changes the outcome. The anatomy of a vector. Every vector has 4 characteristics. The first is the origin, which is the point where the vector starts. It is also called the tail. The second is the direction, which is the orientation of the arrow. It can point north, east, or form an angle such as 45 degrees or 30 degrees. The third is the magnitude, represented by the length of the arrow. A longer arrow represents a larger quantity, while a shorter arrow represents a smaller one. The fourth is the sense. The arrowhead indicates which way the vector points. Changing the arrowhead changes the meaning. For example, walking 10 meters toward the east is not the same as walking 10 meters toward the west. Types of vectors. Vectors can be classified into different types. A free vector can be moved anywhere, as long as its length and direction remain unchanged. Velocity is an example. A sliding vector can move along its own line of action. A force acting on a rigid body is an example. A fixed, or linked, vector has a starting point that cannot be moved. A position vector is an example. If you want to describe the position of an object, you use a fixed vector. Equal, opposite, and unit vectors. Equal vectors have the same magnitude and the same direction, even if they are located in different positions. Opposite vectors have the same magnitude but opposite directions. For example, 5 newtons toward the east and 5 newtons toward the west. A unit vector has a magnitude of 1. Its purpose is to indicate direction only. The unit vectors I hat, j hat, and k hat represent the x, y, and z directions. Cartesian components. A vector can be split into two simpler components. Suppose a vector v forms an angle theta. Instead of describing one vector, it can be represented by two components. The horizontal component is v sub x, and the vertical component is v sub y. Using trigonometry, v sub x equals v multiplied by the cosine of theta, and v sub y equals v multiplied by the sine of theta. These two components completely describe the original vector. For example, if v equals 10 meters and theta equals 30 degrees, then v sub x equals 8.66 meters, and v sub y equals 5 meters. Vector addition. Vectors can be added in two common ways. The first is the head-to-tail method. Move the second vector so that its tail begins at the head of the first vector, then draw the resultant vector. The second is the parallelogram method. Construct a parallelogram using the two vectors. The diagonal represents the resultant. For example, if you walk 5 meters toward the east, then 4 meters toward the north, your displacement is not 9 meters. It is the square root of 5 squared plus 4 squared, which is approximately 6.4 meters toward the northeast. Vector subtraction. Subtracting vectors means adding the opposite vector. Instead of writing a minus b, write a plus negative b. Reverse the direction of vector b, then perform ordinary vector addition. For example, driving 20 kilometers toward the east and subtracting 5 kilometers toward the east is equivalent to adding 5 kilometers toward the west. Scalar multiplication. Multiplying a vector by a number changes its size. A positive scalar keeps the same direction. A negative scalar reverses the direction. For example, 2a is twice as long as a. 0.5a is half as long. Negative 3a is 3 times longer, but points in the opposite direction. Geometry of multiplication. There are 3 kinds of multiplication in vector mathematics. A scalar multiplied by a scalar produces another scalar. A scalar multiplied by a vector produces a vector. For example, mass multiplied by acceleration equals force. A vector multiplied by another vector can produce either the dot product or the cross product. The dot product. The dot product is calculated using the formula a dot b equals the magnitude of a multiplied by the magnitude of b multiplied by the cosine of theta. The result is always a scalar. The dot product measures how much one vector acts in the direction of another. A common example is work. Work equals force dot displacement. If the force and displacement are in the same direction, the work is maximum. If they are perpendicular, the work is zero. The cross product. The cross product is calculated using the formula a cross b equals the magnitude of a multiplied by the magnitude of b multiplied by the sine of theta. The result is always a vector. Its direction is determined by the right-hand rule. Its magnitude equals the area of the parallelogram formed by the 2 vectors. Applications include torque, angular momentum, and magnetic force. The right-hand rule. To use the right-hand rule, point your fingers along vector A, then rotate them toward vector B. Your thumb points in the direction of a cross B. The mixed product. The mixed product is written as a dot, open parenthesis, B cross C, close parenthesis. This quantity gives the volume of the parallelepiped formed by the 3 vectors. If the result is 0, the 3 vectors lie in the same plane. Applications include 3-dimensional geometry, engineering, mechanics, and computer graphics. Vector derivatives. In mechanics, vectors change with time. Position changes. Velocity changes. Acceleration changes. The derivative tells us how fast a vector changes. Velocity equals the derivative of position with respect to time. Acceleration equals the derivative of velocity with respect to time. Kinematics. Finally, kinematics is the study of motion without asking what causes it. The 3 fundamental quantities are position, velocity, and acceleration. Every moving object follows this sequence. Examples include a car, a train, and an airplane. That's all for today. See you in the next lesson.